All right, so good afternoon, everyone. My name is Austin Taylor. I am a security researcher. I'm the director of our cybersecurity research and development team at a company called IronNet Cybersecurity. And the genesis for this talk was I've seen in the community a growing gap between data science and cybersecurity. But not just, I've been to a few data science conferences where they'll talk like very high-level theoretical data science, but how does that actually apply to cybersecurity analysts and in cybersecurity? So the goal for this talk is to leave you with some actionable items you can take back to your security operations center and apply these cybersecurity principles to help you identify. We're going to talk about 3 use cases specifically, so DGA, phishing, and just general anomaly identification that you can use for threat hunting. So as I mentioned, I am the director of cybersecurity at a company called IronNet Cyber. We specialize in network behavioral threat analytics. So anything from beacons, lateral movement, DGA, DNS tunneling. We have use cases, and it's all network-based. So a lot of challenges there, and it's been a long, hard road to the path of detection in the network space. But I'm happy to share a lot of those lessons learned in this presentation. I'm also in the Maryland Air National Guard, where I serve as a cyber warfare operations officer. In my spare time, I contribute to a few open source projects. So Justin and I wrote VulnWhisper, which is a vulnerability aggregator. It aggregates all of your vulnerability reports, enriches it, and then makes the data actionable. And then Flare, actually, I put together, and we're going to talk about that, but that has some analytics built into it, and it also has some enrichments you can use for doing data science. And then Bluewall is a portable, so I'm on a cyber protections team. Anytime we get to a new environment, we have to reconfigure our firewalls. Bluewall is a firewall framework in Python. I have a blog that I haven't updated in a year. There's the URL. And if you care about Twitter, I'm on there as well. Okay, so I'm going to give a high-level overview of machine learning and what is machine learning, try and break down those communication barriers. Then I'm going to show you how to apply machine learning to some use cases, specifically DGA, phishing, and anomaly detection. I'm going to leave you with some questions you can ask of vendors who are making the machine learning claim, which I think are fair questions. And then finally, I'm going to try, if there's enough time, to conclude with a demo of everything I'm talking about. So a high-level overview of machine learning, there's basically 3 types: supervised, unsupervised, and then reinforcement learning, or semi-supervised. And what we run into most of the time is the supervised learning arena. We're not going to cover unsupervised or reinforcement learning here today, but those are other areas to be familiar with. In the community, though, anytime you have a set of labeled data, so if you know that it's malicious or benign, that's something called binary classification. And there's 2 types of supervised machine learning. So you can do classification, which is, I have a little diagram here, shows, this is a student, and a classification problem, it's very binary. They either passed or failed their final exam. But if you're doing regression, it has a continuous value, and then that value is going to fluctuate from a range, like 0 to 100%. So those are the 2 types of machine learning. We're going to cover both in this presentation. The machine learning process is very iterative. I saw a few presentations that called that out. But at first, you want to think about what problem you're trying to solve with machine learning, and then you want to go and grab your data. So whether there's phishing or DGA or whatever the use case is, you want to make sure you have an abundance of data, so that way you can accurately label it. Then you get into that data pre-processing phase, or that's the data janitor phase, as I'd like to call it. Then you create some kind of model based off all the data you've gathered, and then it's time to evaluate your model. So there's something called a test train split. Essentially, if you have 100% of the data, you want to save 30% of that data and not expose that to your machine learning model. That way you can run it back through your model and see how well it's performing. You already know the answers to the test. You just want to see how well your model's doing, and then that'll output some performance scores. And then finally, you just want to continue to improve the performance, whether it's adding features to your models. I'm not going to get too much into that. I am going to cover what features are, but the idea here is it's a very iterative process. So this is something I created. This is called the data science hunting funnel. And the way the top part represents the 100% of your network traffic. So without doing anything, if you're hunting for a threat or something malicious inside of your network environment, you're going to start off with just 100%. You come in, and these are just kind of arbitrary numbers, like approximations. But after you apply some type of machine learning, that's going to reduce your whatever use case you're focusing on. So if it's DGA or DNS tunneling or something you're working towards, or whatever question you're trying to answer in your environment, that's going to reduce your data down to about 10%. From there, I'm a big believer in applying domain knowledge on top of machine learning and pairing it with machine learning. Because machine learning, when done well, it can get you in the right direction, but you're still going to have that problem of false positives as it relates to networks. So you have to have that domain expertise and ask those right questions of the subset of data. And then even with that, after you apply your domain knowledge and your machine learning, it's still very difficult to find actual malicious things in your organization. So this diagram is really just to help set expectations that you're going to apply machine learning and all your domain expertise, and you're going to find some anomalous stuff, but it's going to be very rare that it's going to be bad, like actual bad traffic. So the first thing we're going to cover is DGA. Just to show of hands, who in here is more data scientist and they're kind of getting into the security industry? A few people, and then everyone else is security, and this is, who in here is security and has some familiarity with data science? Awesome. Okay. I consider myself a security researcher first, and I just kind of picked up data science on the side just to help me do my day job. So DGA, if you have ever done any type of security analysis, you've probably run into some form of DGA. Why? Because it's very cheap to register, and you can go on GoDaddy. It's a deterministic value, so the attacker knows what the seed is. You can use it to generate for a large number of domains, and it's very cost effective if you're an attacker, especially if you're using those free domains. So this is a quick Python snippet on how to generate your own DGA. Don't get too wrapped up in the code, but just know that if I'm an attacker, I know that I can create, I know what the deterministic value is. Focus in on that. So that's a date that I'm just passing through the function, and it generates this random domain name for me, right? That's DGA in a nutshell, where the attacker knows at some point in the future, there's going to be, I only need to go register that one domain, but if I'm authoring some type of malware, I can generate 50,000 of those domains, but I only need to register one to be successful. So if a computer's infected and it's trying to reach back out to a C2 server, it calls back to that single domain. That's all I have to register. That's what we're going to try to detect. I'm going to run through this fairly quickly. It's going to be a quick DGA refresher. Put a lot of effort into making sure these arrows were coordinated. So let's give it a shot. So first, the user goes to a malicious website or domain. Then the malware is served back to the user. Finally, these are the synchronous arrows. The user goes to, their computer is now infected, and they're requiring a seed to execute the DGA. However, the attacker already knows what the seed is beforehand, just like I showed you with the date example. Then the malware fetches the time and number, passes it back to the domain generation algorithm, and then generates a domain. Algorithmically generated domains are generated, and then DNS queries are sent off to the server. As a defender, this is what we're going to be familiar with. We're going to look at those algorithmically generated domains, and we want to delineate if something's good or something's bad. So if I'm a bad guy, I'd probably generate 50,000 of them, because I only have to be successful once. The malware receives an IP address of the registered domain and starts the command and control channel. The attacker just registers one domain. He's successful, he or she, and has command and control. We're going to focus on the DGA domains in that section. So I used to think, okay, I can just pick up something if especially when it comes to DGA, I can just look for very long labels, or there are some nice rules that will help get you in the right direction with DGA, but I found data science to be an extremely effective measure for identifying and breaking up my data. So we're going to go through this scenario together. A piece of malware has infected a computer on your network. It's making a request to domains using DGA in an attempt to communicate back to a C2 server. So there's this network analytic framework called Flare. It comes with a lot of, I found myself when I was going through this machine learning journey of trying to become better at data science and better at machine learning, of writing a lot of these little snippets for enrichments. So one example is, there's the Levenstein formula in there. There's Markov models in there. And I found myself asking a lot of the same questions when building these models. So I just put it into this framework and just released it, made it open source back to the community to try and help bridge the gap. So inside Flare, this is all in the Python notebook. If you saw my Lightning talk earlier, we covered Jupyter notebooks a little bit, but that's what this outputs from. So here I'm importing, I know it's a little hard to see, but from Flare data science features, I'm importing a DGA classifier. There's a classifier for DGA just built right into Flare. What's cool about it is it uses random forest, and I'm going to take a little tactical pause here. What I love about this talk right now is I'm going to walk through, yes, it's good, I'm going to show you use cases and how you can use machine learning, but I'm going to talk a little more to the data science and the machine learning so we can try and better understand it as a community. So random forest is one variant. It's an algorithm you can use for supervised machine learning. And then it uses something called Engrams, and then it uses, of course, labeled data. There's plenty of labeled data out there for DGA. For the benign data, it uses Alexa top 1 million. I also just recently added Majestic 1 million to it, just because it's free, and the score went up a little bit. And then it also it does domain TLD extraction. So, there's subdomains, maybe there's like some random subdomain, and then google.com. It'll extract out just the google.com portions for you, and then compare that up against Alexa. So what is an engram? You hear that a lot in the community. So an engram is, it looks at the transitional properties and then calculates some type of value. So in here I have two examples. On the left-hand side, it's showing an order of 2, or this would also be known as a bigram, because 2. And you can see the way that this is working. So it says, the sentence is, this is an example of how engrams are generated with an order of 2. And then it takes the first 2 words, this is n, an example. And then when the same thing happens when you say, do it for 3. This is an example, and so on and so forth. That's showing you how engrams apply to words, but you can also apply the same logic to characters inside of a word. And start inspecting the transitional properties for what's normal in your environment and assign a score to that. DGA labeled data sources, I'd like to think APT33 and APT3, but there's all kinds of malicious data sources, and the DGA, the actual algorithms, are available. So what that allows you to do is, Defender is pull those DGA algorithms down and then just generate your own domains. And now you're building your labeled data set. For benign data, the English dictionary works well, the Alexa top 1 million, Cisco, Umbrella, and Majestic million. And I'd even encourage you to put your own DNS domains in there. But someone brought up a point earlier, well, if you're already infected, then you'd be training your model with bad domains. So that's a good starting point. To get my data, I just exported all of my DNS records from my personal server. Let me just do a quick sanitization check. All right, that looks good. Yeah, so I just went into Elasticsearch, exported all of my DNS requests. So part of this mission is we're trying to find this DGA domain, right? So one of the things we can do is strip out the top-level domains, and this is as easy as, I'm going to do an example of how to apply Flare's prediction method, but on the left-hand side here, you have the DNS name, how many times it's present in the environment, the top-level domain stripped out, and then the DGA prediction algorithm. It has two outputs. It'll either say, this is DGA or this is legit. And that's pretty nice as a defender, because now we're doing binary classification, and we can say, well, just show me everything that's DGA, right? So I'm applying a filter in that column that has 84 next to it, or the row. This is still a lot of results. So I started with, I think, 200,000 results. I'm down to 240, but as a defender, 240 alerts is way too many for me to process in a day, and this is just for one use case, right? So I imported Alexa. I filtered out anything that has the, anything that's in Alexa. I said, all right, I'll just make that my whitelist and not show that. And that got me down to 78 results. And here we have the domain. So 57 results. There's the domain we were looking for. That's the one we generated a few slides earlier. And you can see, like, this is all the results that were left. So we have 57. But I also included the false positives in there on purpose, because I could have made this presentation like, yep, look at that. It just caught the DGA. And, but the real world is you're going to have false positives. Machine learning, and especially when you get into Engrams, you know, choosing between 2 or 3 or however far out you want to go, that's going to have an impact on how well your model does. So I've noticed with words or shorter domains, it has a harder time calculating entropy and like change. So you'll get some false positives with that. So I could have applied a filter, you know, assuming shorter domains cost more to register and it's a .com, I could have probably filtered those out, but wanted to include it in here just to set the expectations. So as far as our case goes, we are going to pass that domain over to the analyst, isolate the infected host, unplug all the wires, and there's our domain. Begin the endpoint investigation, case solved, nice job, everyone. So that's good for the analyst, but if you're a manager, you're like, well, can you explain what happened? And sometimes, if in the machine learning world, you're like, well, I used this machine learning model, and then it made a prediction for me, it kind of led me in the right direction. But what if you could explain the machine learning model's thought process? And that's where decision trees are really cool, because you can actually visualize the steps that the machine learning model took and how it arrived to its conclusion. So they're very easy to interpret, highly recommended. Anytime you're doing like regression or an ensemble, there's usually a decision tree you can use for it. The challenge here is decision trees can be very difficult to read and render visually as you add more features. So I'll break out what the features were in a second. Actually, this is a really good example of a basic decision tree. So the dependent variable is play. You want to know if you should play or not for the day. All right, so the input is you're going to play. Then you have a few features. Well, if it's sunny outside, then okay, the likelihood of me going to play is 2. The likelihood of me not playing is 3. But then I have some more qualifying features, like, well, what's the humidity like? Is it greater than 70% or less than or equal to 70? You know, and that's going to influence the decision of whether or not you go outside to play for the day. This was the results visually from the DGA prediction that I just showed you. Now, you can show that to your manager, and they might say, hey, can you make that a little bigger? So naturally, you're going to say, enhance. And then you're getting down to the area of the tree. You're like, man, I still can't see that. So you got to enhance. And finally, you get down to this bottom part, but we can do a little bit better. And this is the bottom part of the tree where the DGA, the model is making the final determination of whether or not something is DGA. So it's the features we have are entropy. Now you can see I'm going through, I have the features on the left, and then the red boxes as they're coming down the tree here. So it's like, okay, the entropy is less than or equal to 2.4. Move on to the next one. The Alexa Engrams are equal to a value. And it just goes down and further. And you can see at the very bottom, I know it's a little hard to see. I'm going to try this slide. Yeah. So you can see how it has the class where it's DGA or class legit. it's making that classification based off those values and just filtering its way down the tree. It's pretty cool, huh? So that's DGA. We're going to move on to phishing. So streaming phish is an application, phishing something that's near and dear to all of our heart. I think it's the #1 attack vector and probably arguably the most damaging. Wes Connell created a framework called Streaming Phish. He also does behavioral analytics. He's over at Pattern X. And the framework uses supervised machine learning to detect phishing domains, and it runs against the certificate transparency log network to validate the results. I actually have it running in the background right now. So if you're not familiar with the certificate transparency log, what that is, I'm going to do a quick refresher in a second. You can download this for free at the URL. So there's this thing called CertStream, and what it does is it provides access to all of the newly registered certificates and then just creates a feed for you. So those are certificates being registered under a certain certificate authority. And you can run Streaming Phish live, and it'll output scores against those, so you can see how well it's performing. But you can also run this live in your network. So as a refresher for certificate transparency flow, our current TLS or SSL system, you have certificate authority. They issue a certificate for example.com. Then when you go and visit example.com, your client does the exchange for SSL cert. That's what we have today. Chrome has enforced certificate transparency. So if a domain is not compliant with certificate transparency, now you'll get that error, like, hey, be careful. This could be a dangerous site. So with certificate transparency, all it's doing is it's taking the log server, and then saying, okay, we want the certificate authority submission, and it generates this thing called the log response. All it essentially is doing is generating a log entry into a certificate transparency server. So that makes it available to you as a defender to go through and validate, is this a legit certificate? Like, did this certificate authority actually issue the certificate to this domain? Because if you're a bad guy and you've hacked a certificate authority, you can just start generating your own certificates to Facebook or whoever owns that. And then you can do man-in-the-middle type attacks, or phishing becomes a lot easier. So what I love about this, it uses logistic regression, and it will make scores for you and put it into different categories. So it's either high, suspicious, or low. And you can see here, this is the example on the GitHub stream. It either says it's phishing or it's not phishing based off the range. So it uses a logarithmic range. And it's between 0 and 1. The closer it is to 1, the higher likelihood of it being phishing. This is what it looks like. I ran this yesterday, and I made my own classifier in a few seconds. And you can see it has the certificate authority on the left-hand side. And then these are the domains that were being registered, pulling it from CertStream. And you can see some of these are pretty fishy. I had to, I'm sorry. So you can see, so the score is 0.995, 0.990, and then you got a twitter.com-o.d, but it has a lower score. So those are things you can just filter out right away. Moving into anomaly detection. So there's a lot of ways to do anomaly detection. This diagram is a good starting point to know which application. First, you have to think about your use case, and then there's these things called univariate or multivariate variables. If it's like a domain, for example, and that's what you're trying to make a determination on, that'd be univariate. But if there's a lot of extra features, then you can get, that's when it's probably a good time to look at clustering or doing some type of clustering and Markov chains. We are going to focus on just doing Markov chains for domains. User agents. So we're going to identify anomalous user agents in our environment using Markov chains. To get the data, I just went into my Elasticsearch stack, and I just exported all of the user agents using the quick little value count that Kibana provides. But with since we're analyzing transitions between characters, we want to prep the data. This gets into the data janitor role. So this is a little hard to read, but what it's showing is, back here, I just have one user agent. So it's Mozilla 5.0, and that's been seen in my environment 2,700 times. I wrote a quick little Python script that exploded that out. So inside of my user agent big strings text file, I'm going to see that same user agent 2,700 times, and it's OK. It kind of goes against like what we're trained to do, is just like minimize. But when you're using the Markov model or anything that's looking at transitions, you want the raw data. So that way it can say, OK, this is normal. And these character transitions happen more often in the environment. So to train the data, you can use Flare. There's a Markov model class. And then that number is the order, or you can think of it as the Engrams that we covered earlier. We're loading the data from this file. This is what the file looks like. And then each transition receives a log likelihood score. Like anytime I have the letters M, O, Z, the likelihood of it being followed by an I for my user agents is 1, which is 100% of the time. Because this is Mozilla. So in the user agent land, like, there's a high chance for that. So these are 2 user agents I have. What's really neat about the Markov model is you can start simulating things once you've built and trained your model. So here's an actual user agent I pulled down. And once you run the simulated command, this is a generated user agent from the Markov model. So it took all of those transitional properties and then made its own user agent. So how do we operationalize this? Well, it's nice that we can make fake user agents all day long or simulate them, but we need to assign some kind of score. So there's 2 user agents here. The top one's the Google Chrome Mozilla user agent, which is a legit user agent. Can anyone tell me what the bottom one is? It's uncommon for sure. Is it legit? Yep, I heard it a few times. So that's the shell shock. It's the start of a shell shock. And then it's got some other goodness tagged onto the back there. So what does that look like when we assign a likelihood score to it? Well, on the top, you can see the closer to the score is to 0, on a logarithmic scale, the closer it is to 0 is the more common it's seen in your environment. Whereas the further out, like I think this scale goes to 40, it's more uncommon. So what you're doing is you're enriching the data and positioning your analyst to, they don't have to do any machine learning, but they can just, hey, show me everything that has, like, sort all of these scores in descending order, and then I want to look at the least common user agents in my environment. I'm sorry, ascending. So some recommendations on how to operationalize the Markov model. You can use it for network. For doing network detection, look at fields like the subject name issuer in TLS, user agents for HTTP, DNS labels. I found some really cool stuff using cipher suite detection inside of the network. I found some like really old computers and outdated browsers doing that. And then TLS common name. And then for the, you can also apply this for the host as well. Things like file names, host names, registry keys. Usually your host names assigned to your organization have some type of schema it follows. So if there's, it's a great way to find rogue host. And of course, command line. That one varies, the mileage varies. I have found some, it was pretty easy to detect an IEX like droplet in PowerShell through this, but that's the coolest thing I found so far. I'm ending with the questions for vendors. I didn't get into like performance metrics on things like how do you know if your model's doing well, but I wanted to add this to the presentation because I feel like that's where the industry's at right now. And this isn't like an interrogation of the vendor, but these are questions they should probably be able to answer if they're making the machine learning claim. So you as a consumer can go through here, and these slides will be available, and ask the vendor, like, hey, are you doing supervised or unsupervised learning? Well, are you doing classification or regression? have more of an informed conversation with them. Tracking true positive rates and false positive rates, how can they make a recommendation of their product if they're not tracking like how successful it is? So fair questions, it's just really breaking down that communication barrier, so that way we can start speaking the same language and talking to each other. So I'm going to do a quick demo. I have 3 minutes left. Let's see. So I've been letting streaming fish run, and this is what it's found so far. Let's see if anything else comes in. So people are trying to register fake domain names all the time. Some of the features it uses too is it will look for association with like Apple or Microsoft or well-known domains, and then it uses the Levenstein distance to determine if something is like how close is it to that well-known brand name, and then make a prediction on there. So new things are rolling right in. You can see Instagram just got hit, and these are actionable lists. Imagine if this is running in your environment. You can just say, hey, these are the phishing URLs or links that we've got for the day. Here you go. Take a look to see if any were successful, if any had like 200 OKs, or did any of our employees actually go to one of these sites? It's a good way to start an investigation. So that's the demo for phishing. For DGA, so it's as easy as setting up, importing the DGA classifier. If you're not familiar with Python, it's okay. I mean, this will be available to you. I just want to show you how quick and easy it is to make a determination if something is DGA or legit. So once you have your model trained, you can start making these predictions like, I can do Facebook.com, that's legit. As soon as I start adding some randomness to the domain, then it just outputs, yep, that's DGA. So in this example, I'll do google.com, does DGA. I can just keep adding to the list. And that's it. That's what you get back. So imagine if you have that in your sim where you're tagging everything that comes in. This is either legit or DGA. Now you've given your analyst a much smaller list of things to look at instead of just like, hey, go to town and look at everything. The last thing I want to share is the Markov chain example. So I love this demo because you can simulate Shakespeare or Sherlock Holmes. So I actually downloaded all of the Shakespeare sonnets, and it's like, well, let's point the Markov model at this and see how well it does. So in Shakespeare sonnets, I had to clean it up a little bit. I'm using Engram or trigram, so order of 3. Training up my Markov model. We'll do print m simulate. Do 1,000. And this is the machine generating these sonnets. Now, I could have took the numbers out, but looks, show, say, be disgrace, who's a so flatter? Let me generate a new one. Thus love thy bry and a bereavement that end on shout of day. And you get the idea. But you can apply that same thing to user agents. So that was the example I gave earlier, where I have my common user agent and then a shell shock user agent. And I could just keep generating new user agents based off everything I've given it earlier. So that's why I really love Markov chains. If you're bored on a Friday night, you just want to play around with the Markov chains. So tool chart, I broke it down. Big shout out to Wes Connell for coming up with Streaming Fish. It's a big contribution to the community. I don't think it's received a lot of attention on GitHub, but it works really well. If you're doing DGA, have random forest example with Flare, phishing using logistic regression and streaming fish, and then anomaly, just general anomaly detection. You can use Markov chains, or you can download freak.py, which Eric Conrad covered earlier. Covers something very similar to that. Have links at the bottom. In summary, we performed a machine learning overview, how to apply machine learning to given use cases, good questions to ask some vendors, and did a quick demo. All right.